Hello, in this video I will review the answers for the review of quiz number 3. We begin with a contingency table involving age groups and types of investments. The very first step in tackling a problem like this is we have to total each column and each row. And then finally, to get the grand total, we have to either add up all the totals of the columns or all the totals of the rows to get 400. We begin with the very first question. It states the person is 40 to 49 or invest in mutual funds. So or informs us that we're applying one of our addition rules. And we have to be very careful because there may be an overlap between these two variables. In fact, in this case, there is. So we have to avoid double counting by subtracting out the overlap. First, we compute the chance that someone is between 40 to 49. Well, between 40 to 49, there's 71 people. So 71 out of 400. Remember, or means to add, so plus. How many people invest in mutual funds? 47 do, so 47 out of 400. But we have to be very careful because we're double counting this one person who's 40 to 49 and invest in mutual funds. So make sure to subtract out 1 out of 100 to get an answer of 117 out of 400. For part B, it states that the person is 70 to 79 and, so doesn't mean or. And does not mean to add. And means you're looking for what's common to the two variables. And the other variable is invest in real estate. So we're looking for a person who's in this age range and invest in real estate. Well, if we look at that age range and real estate, there's 3. The answer is 3 out of 400. For part C, it says the person is 60 to 69 given that the person invests in stocks. When you see the phrase given that, you're thinking of conditional probability. The condition is invest in stocks. So whenever we have a conditional probability, we shrink our sample space to the condition. So in other words, we only focus on this one column involving stocks. And in that column, how many people are aged 60 to 69? 12 out of 104. So 12 out of 104 reduces to 3 out of 26. For part D, it says the person invests in businesses given that the person is 30 to 39. So once again, we have the phrase given that conditional probability, the condition is 30 to 39. So we focus on not the column, but the row of the people that are aged 30 to 39. That's 56 people. And the number of people who invest in businesses is 8. So 8 out of 56 reduces to 1/7. Moving on to number 2, we're computing probabilities involving 2 dice. Now remember, whenever you have 2 dice, the sample space is 6 times 6, 36 possibilities in total. My recommendation is to use the sample space I provided to you involving 2 dice. So let's review how to use this sample space. Let me shrink it a bit to about there. Let me go a little smaller. All right, here we go. So we have to treat each pair of dice as an outcome. So the white and blue is one outcome. So to get a sum of 2, there's only one chance of that happening. And then if you count up all the pairs, you'll see that the total number of pairs is 36. So let's go ahead and answer part A. It says we want to know what's the chance if we toss 2 dice the result is a sum of 7 or 11, well, we count all the sums of 7. 1, 2, 3, 4, 5, 6. Count all the sums of 11. 1, 2. So 6 plus 2 is 8 out of 36, which is 2/9. The result is a sum that is odd and between 2 and 8. When you see the word and, that means it has to have both properties. So we're looking for all the odd sums between 2 and 8. Well, here's 2. So 3 is odd, so let's count it. 1, 2. 4 is not odd. 5 is odd, so 1, 2, 3, 4, 5, 6. 6 is not odd, but 7 is. So far we had 6 outcomes, so 6, 7, 8, 9, 10, 11, 12. Thus, there are 12 outcomes out of 36, which reduces to 1/3. And then finally, for part C, it says the result is 13. That's impossible because the maximum sum is 12. So whenever an event cannot occur, it's 0. Let's look at number 3. So number 3 says a card is selected from a standard deck. Compute the following probabilities. The card is a numbered card. Well, let's look at our deck of cards again. So I do provide that on page 2 of our sample space. So we have our deck of cards. Let's count all the numbered cards. So we have, let's see, let's first count the numbered cards here. There's 4 of each type, so we'll just multiply it by 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 4 is 36. Out of 52, that's going to reduce to 9/13. For part B, it says the card is red and a face card. So it has to have both properties. All we're really looking for are the red face cards. So let's count the red face cards. Remember, the face cards are the jack, queens, and kings. So the red face cards, there's 3 here, plus another 3. That's 6. 6 out of 52 reduces to 3 out of 26. And then part C, it's saying the card is a diamond or a 5 or an even numbered card. So when we say even numbered card, we're just thinking of the numbered cards only, the even of numbered cards. So first of all, the diamonds, there's 13 diamonds. The 5, there's 4 5s. And then the even numbered cards, let's count the even numbered cards. So we have 2 is even, so 4. 4 is even, that's going to be 8. 6 is even, 12 cards. 8 is even, 16. And then 10 is even, 20. So that's how we get 20 out of 52. And then we have to avoid double counting, so we have to subtract out the 5 of diamonds and the even diamond cards. So let's go back because we're double counting them. So we have to subtract out the 2 of diamonds, there's 1, the 4 of diamonds, 2, the 5 of diamonds, 3, the 6 of diamonds, 4, the 8 of diamonds, 5, and the 10 of diamonds, 6. Because we've already counted them. We don't double count in computing these probabilities. That's why we subtract out 6 out of 52. That's going to give us 31 out of 52. For number 4, we're using the multiplication rule. It says 4 cards are selected without replacement from a standard deck. Compute the following. So when we're selecting 4 cards, and remember it's without replacement, so that means that the events are dependent. So each probability is slightly changing. So we start with the first card being a spade, because we want all cards to be a spade. So let's count the number of spades. Well, there's 13 spades out of 52. So that's our starting point. So we have 13 out of 52. That's our first card, times. Now we select a second card, but whatever card we selected here, we cannot select again, right? Because it's been removed. We're selecting them without replacement. So now we only have 12 cards left to choose from out of 51. And then whatever card we select here, we cannot use again. So now it's 11 out of 50. And then finally, for the last card, 10 out of 49. That's going to reduce to, or in this case, we'll just make it a decimal. I think the calculator will automatically do so, 0.0026. Now for part B, it says none of the cards are spades. So none of the 4 cards are spades. Well, let's count all the non-spades, right? So we want to pick a card that is not a spade. So if we exclude the spade, these are the spades, sorry about that. If we exclude the spades, we have 13 of each type. We have to choose from these cards here. So 13 times 3 is 39 out of 52 for the first card. And then once again, we just reduce it by 1 because we're removing a card for each selection. So then 38 out of 51 times 37 out of 50 times 36 out of 49, which is 0.304. And then finally, for the last part, it says at least one of the 4 cards is a spade. Well, whenever you see the phrase at least one, you want to envision this formula here. It's the probability of at least one is all spade in this case is 1 minus the probability that none is a spade. Well, this is the probability that we computed in part B. So all we have to do to answer C is compute 1 minus 0.304, and the answer is 0.696. Let's go on to number 5. Number 5 says the chance that a person has a bachelor's degree is around 35%. If 3 people are selected at random, what's the chance of computing the following probabilities? Well, here we're selecting a person from millions, right? And actually we're picking 3 people. So whenever we do this, we're picking a small sample from a large population. The events are independent, meaning the probabilities remain the same per selection. So if we're picking 3 people that have a bachelor's degree, then each person will have the same probability, 0.35. We raise it to the 3rd power. That's a quick way of calculating this because it's really 0.35 times itself 3 times. And we're going to get 0.043 as the answer. Now, none of them have a bachelor's degree. First, we have to calculate the chance that a person does not have a bachelor's degree. So 1 minus 0.35 is 0.65. And then since we're choosing 3 of them, it's 0.65 to the 3rd power, 0.275. And then finally, for part C, it says at least one of them have a bachelor's degree. Well, once again, we're using our at least one formula. It's 1 minus none have a bachelor's degree, while 1 minus, we just calculated none have a bachelor's degree. 1 minus 0.275 is 0.725. Number 6 states the following. The chance that a person watches a movie on a Friday night is 45%. The chance that the person watches a movie and purchases popcorn is 26%. What is the chance that a person will purchase popcorn given that the person watches a movie on a Friday night? So this is a conditional probability because we see the phrase given that. So according to our formula, let me just kind of clarify this here. The formula is written in this manner. So the probability that a person purchases popcorn, given that they watch a movie, is the probability that they do both purchased popcorn, and watched a movie, divided by the probability that they watched a movie. So all we're really doing in this problem is taking 26%, which we write as a decimal 0.26, and dividing by the condition 45% or 0.45. That's going to give us 0.578, which if we wanted to, we can convert to a percent, 57.8%. And thanks for watching the video.